boys and girls, our objective for today, let's go ahead and read it together. Ready? 1, 2, 3.
I will identify different number using visual fraction model.
Okay, so our objective for today is that we will identify and compare fractions with different numerators and denominators by using those visual fraction models. Okay, so before we jump into the lesson, let's go ahead and quickly review our key vocabulary, where we have fraction. Fraction, we said that is a part of a whole expressed as a numerator and denominator. Then we have that numerator, right? The top of a fraction, right? What is a numerator?
The top of the fraction.
Right? And we have that denominator, right? The bottom number of a fraction. What is a denominator?
The bottom number of the fraction.
And you're going to hear me, right, throughout the lesson say comparing. Compare. What is compare? Well, comparing is determining which two fractions are going to be greater, less, or equal. Okay? And then we have equivalent fractions, where fractions that represent the same value but have a different numerator and denominator, right? And as you can see, we brought in again those crocodiles, right? That represents greater than, less than, and equal. Okay? So as we go through our lesson, we're gonna bring them back. Okay? So really quick, comparing those fractions. My iPad turned off on me. Let me turn it back on. Okay, 4691. Okay, as we jump into our lesson, let's keep in mind our success criteria. What we want to be able to be successful for this lesson. So in our success criteria, we're going to go ahead and use visual fractions models, whether it's circles, right, those pizzas, right, whether it's those fraction bars, okay, to represent which fractions are going to be different numerators and denominators. We're also going to be comparing the fractions by reasoning about their size using those visual models, so comparing, and then we're going to be explaining the comparison and justifying the answer, and correctly identify which fraction is greater than, less, or equal based on the models. Okay, so let's go ahead and jump into our examples. Okay. You can see me over here? Yes. All right. So boys and girls, when we compare fractions, we need to figure out which one is bigger, which one is smaller, or they are the same size, right? We can use again those tools like fraction bars, number lines, or those fraction circles, right, to help us see their sizes. Okay, so for example, let's go ahead and look at 1/2. Okay, so I'm going to use our fraction circles here so you can see. Okay, so we have 1/2. Okay, and I'm also going to go ahead and draw 1/3. Okay, I need your full attention first. Okay. Okay, so I'm going to do also 1/3. I'm going to draw 1/3. Okay. Now you can see, so we have 1/2, and then we have 1/3. Okay. Now you can see that 1/2 takes up more than space than 1/3. Can you see that? Okay. That's because 1/2, boys and girls, is the whole that is divided into fewer parts. So each part is bigger. Okay. So now, how can we solve through these fractions, right? To determine which fraction is going to be greater than or less than. Okay. So I'm going to show you a butterfly method. Okay. The butterfly method is gonna help us identify again which fraction is greater than or less than or equal to, okay? So by using it, I'm going to get, again, 1/2 here, and I also have 1/3. Okay, so all I just did, I brought it to the side, okay? So the butterfly method, so I'm going to create a butterfly here. Do you see that? Okay, it looks like a butterfly, right? Okay, I'm going to go ahead and use my method of multiplication. Okay, I'm going to cross multiply. So we have 3 times 1 is 3. We have 2 times 1 is 2. Okay, now if we take a look at our numbers 3 and 2, which one is greater? 3 or 2? 3. So that means that 1/2 is greater than 1/3. Okay, now by looking at our symbols, right? Greater than. Remember that the crocodile eats that greatest number, right? So if I were to place my symbol, okay, greater than. Yes? Is that correct?
Yes.
Yes. So 1/2 is greater than 1/3. So let's repeat that again. 1/2
1/2
is greater than
is greater than
1/3.
1/3.
Okay, so very good. So now let's go ahead and jump into another example. Okay, so I am going to go ahead and again use a circle model. Okay, this time I'm going to cut it in 4. Okay, I'm going to shade in one part. Okay, so this one again represents 1/4, and I have another one. Okay, but this one is going to be 1, 2, 3, 4, 5, 6. So this one is going to represent, let's see, 1, 2, 3, 4. 4, 6. Okay? 4, 6. Okay? So now that I have created my models, right? Now that I have identified what fraction is considered that model, okay? So I'm going to go ahead and bring it to the side again. That way I can work through it and see which fraction is going to be considered greater than or less than. Okay, so now I'm going to be comparing them. Let's see. So 1/4 and 4/6. Again, I'm going to go ahead and use my butterfly method. Okay. As you can see, right? And we can even place the antennas for this butterfly. Can you see that? Okay. Again, I want to use that multiplication method. So I'm going to cross multiply. So 6 times 1 is? 6. And then we have 4 times 4 is? 16. Okay? So now that I have cross multiplied, which one is greater? 6 or 16? 16. So that means 4, 6 is greater than 1/4. So 4, 6 is greater than 1/4. Okay? Ms. Robles, yes, I am understanding this. Let's do some more examples. Very good. Okay? All right. Let's go ahead and do one more. I'm going to do again a circle model. Okay? And this time I'm going to cut it into 8 pieces. 4, 6, 8. Okay? And then we have another one where this one is going to be cut into 1, 2, 3, 4, 5, 6. So 6. And then we have 8 here. So this one I'm gonna go ahead and shade in 2 8s. And this one is going to be up to 5. 5, 6. Okay? Alright. So now again I'm going to take my fractions here to the side because I want to go ahead and solve and compare to see which fraction is greater than or less than. Okay, so again, I'm going to use my butterfly method. Okay. All right. And what symbol should I place in the middle? Times, right? That multiplication, times. I'm going to go ahead and create my antennas. That way I can go ahead and cross multiply. So I have 6 times 2 is 12. And then we have 8 times 5 where we have 40. Okay, now that I have these numbers set right here, solved, we can see that which one will be greater, 12 or 40? 40, right? So that means which fraction will be greater than? 5, 6, right? Why? Because it's here on top of our 40, right? So we have 5, 6, which is greater than. Greater than 2 8s. Okay? Right? Okay. Now, let me ask you really quick. Why do you think understanding these fractions is useful? For example, when you are cooking, shopping, or dividing any tasks. Why are these fractions useful? Okay, again, when you are cooking, shopping, or dividing those tasks. Humberto?
For knowing what would be the best thing to buy or how to divide it. Like,
okay, so knowing what's gonna be the best thing to buy or knowing how to divide it, can you elaborate a little bit more on that?
for dividing is like you need to divide it and one pizza into 8 easy because there's 8 in your family and then you don't know how you will do that cut and then like you how many pieces will be left and it will be 8 because all your family are 8 persons and it will be correct. You
Okay.
can see how it will be correct to each person to the cantidad.
The total of it?
Yes.
Okay, very good. So I want you to think very, very good connection. Thank you. Here's your tickets. Come and get your tickets. Humberto? Tickets. So yes, very important that also when you are measuring those ingredients, right? When you are making a cake, do you think it's important to know the measurement where you're going to make a cake?
Yes.
Yes, right? So for example, if a recipe of a cake is telling you, right, to go ahead and add 3/4 of a cup of sugar, right? But you want to make half of the cake, you want to make half of the recipe, you want to use the fractions to calculate that you're going to need instead 3/8, right? And instead of 3/4, if you're making half of it, right, you're going to need 3/8. Okay? So yes, 3/8 of a sugar, cup of a sugar. So yes, it is very important that we understand these fractions, not only right here during math, right, but also in real life. Okay? All right. So now let's move on. In the center of your groups, each group has a model, whether it's a circle model or a bar model, okay? But you're going to be working in your groups. But before you jump into your group activity, I want you to think about what we just did, what I just showed you, right? Where I used those visual fraction models, I used those circles to represent the fractions with different numerators and denominators. Okay, I compared, right? I compared the fractions by reasoning about the size. So comparing not only those fractions, but thinking about how is it that these models, right? Why is it that these models are greater and which ones are less? Okay. Think about how we explain the comparison and correctly identify which fraction as we went through the butterfly method, right? We solved it and we identified which fraction is greater than, less than, or equal to. Okay, so as we are working in our groups, again, start thinking about that success criteria. Okay, so again, in your groups, you have a model. Okay, some of you have a bar model, some of you have circle models. Okay, so in your groups, you're going to not only identify what is the fraction for each model, but you're also going to be comparing. Okay, you're going to be comparing to see which model, okay, is greater than or less than or equal to. Okay, do we have any questions?
No.
No? Okay, so I'm going to give you about, let's see, 5 minutes to work in your groups. I'll be walking around. Okay, 5 minutes. Go ahead and okay? 5 minutes. Go ahead. So think about that key vocabulary as you are talking with your groups, right? Greater than, less than, denominators, numerators, okay? Okay? All right, so yes, so first identify what will be the fraction for this model, 4/8, and this one? 3/8, okay? Then? All right, I'll come back. This group, what do we have? Oh, you can solve it here, it's fine. What do we have? Three, 6, okay, that will be considered 3/6. What about the other model? 5/6, very good. Okay, so now what is it that we do? Butterfly method, good. Okay, I want you to think about the models. Okay, before you even draw the butterfly method, right? Thinking about the models, which one do you think will be the greatest fraction? Why? If you say 5/6, why? It has more, but look at the model. Okay? Do you think this model 3/6 has more space, or 5/6 has more space? 3/6. There you go. So go ahead and continue with that butterfly method. What do we have over here? We have circle models. Okay. This one represents what fraction? 5/6, and this one? 2/6, right? By just looking at the models, right? Which one do you think is greater? Okay. 5/6? Are you sure?
Yes.
Tell me why.
Because if we do the butterfly method, we multiply 6 times 2 equals 12 and 6 times 5 30.
5, 6, 30. Okay. All right. Let me see. So we have 5, 6, 1, 2, 3, 4, 5, 6, 5, 6, 2, 6. Okay. 30, 30. So 5, 6. All right. Good. Over here. 2 minutes. What do we have here? 8, 3, 4, 8. So we have 3 8s here and here. 3, 4, 8. Okay. All right. So make sure we are writing and working in the group. Okay. All right. I really like how group 3 has those conversations where they're using that key vocabulary, fractions, right? They're using comparing. I heard someone say comparing. So very, very good. I like how you guys are using that key vocabulary. Yeah?
5, 6 is
4, 8 is greater than 8.
Because 5 times 6 is 30. No, if we do the butterfly method, we multiply 6 times 2 equals 12 and 6 times 5
Okay, one more minute.
30.
here, group 7. What do we have?
It's gonna be 5, 10.
Good. All right, STOP.
Stop.
Can I please have somebody from group 7 coming up? Once mine. There we go. Let me go ahead and put the 5 lines. Okay, can you please show us your model? What is your model? Where's your model? Or you have it? All right, zoom it in, please. Zoom it in more. Right over. All right. All right, so can you please explain what type of model do you have? Do you have a circle model or a bar model? A bar model. All right. So now, how is it that you guys compare those fractions? Okay, but yes, you use the butterfly method, and I did see that you guys identified those fractions, right? By looking at the model. So you have, what fraction do we have here? 4 12s and 6 12s, all right? And I see that you also, when you guys work through that butterfly method, okay, I see that you guys cross multiply. 12 times 4 is 48, and then 12 times 6 is 72. Very good. Okay, so now if we look at 48 and 72, which one would be greater? What number is greater?
672.
72, right? 72, so that means which fraction would be greater?
612.
6 12. 6 12s, right? Okay, is your symbol correct?
Yes.
6 12s is greater than 4 12s.
Yes.
Is your symbol correct?
Yes. No.
Remember that the crocodile eats what?
The
The greatest number. So her symbol should be looking the other way around, 6 12s. Okay, but because right now you're telling me that 4 12s is actually greater than 6 12s. So remember that the crocodile always eats the greatest and biggest number. Okay, but very, very good. Let's go ahead and give group 7 a roller coaster here. Ready? 1, 2, 3.
Woo!
Very good. Okay, so now let me have one more group. Let me have Dominic, come over. Bring your model, please. Okay. All the way up. Let me see the model that you guys have so we can see it clearly over here. Right there. We can see it. Yep, and zoom it out. Alright. Alright, so do we have a circle model or a bar model?
Circle.
Very good. By looking at this circle model, we can identify that we have, let's see, how many slices of pizza?
8.
Right? 1, 2, 3, 4, 5, 6, 7, 8. 8. So we can see that we have a total, right, of 8 slices, right, of pizza. And then how many did Ms. Robles eat?
2.
2 or 3?
3.
3. So our fraction is going to be looking how?
3. 8.
3 eighths, right? So we have 3 eighths. Go ahead and solve it. Ready? That's fine. 3 eighths. Good. And then our next pizza, right? Our next circle fraction model, we have how many slices in total?
1, 2, 3, 4, 5, 6, 7, 8.
Again, we have a total of 8. Go ahead and how many slices of pizza did Ms. Robles eat? 1, 2, 3, 4, 5. So our fraction will be looking how?
5, 8.
5 eighths. Go ahead and write it down, Dominic. 5/8. Okay, very good. Now, if I were to see, right, so we have our fraction set. So now we can go ahead and do that butterfly method, right, to help us compare those fractions to see which one is greater than, which one is less than, or maybe they're equal. I don't know. Let's see. So let's go ahead and work through that butterfly method. Yep. Yes. Your tooth fell. Go to the nurse. Right in the middle of the lesson, your tooth falls. Interesting. All right. All right, so I see that you're using that butterfly method with those nice antennas. Cross multiplying. I think we have them backwards. What is 8 times 5?
40.
Let's help Dominic. What is 8 times 5?
40.
40, not 24. Okay. We have 8 times 5 is 40 up here, and then 8 times 3, 24 up here. So we have them backwards. Do you see that? Alright. So by just looking in our antennas, right? Which one is greater, 24 or 40? 40. So that means which fraction will be the greatest one? 5/8 or 3/8? 5/8. So go ahead and write your symbol to see. Let's see. Remember that the crocodile eats the greatest number. Is Dominic correct? Yes or no? Yes. I also agree with Dominic. Let's go ahead and give him a burger shear. We put it on the grill, we flip it, and well done. And this also goes to group 1, or group 2, sorry, because they all collaborated as a group. All right, very good. You may go back to your seats. Yes. All right. So before I give you a worksheet for you guys to work on it individually, do we have any questions?
No.
Okay. All right. So keep in mind our objective, right, where we are identifying and comparing with different numerators and denominators by using those visual fraction models. Okay. So I'm going to go ahead and pass these worksheets around. Okay, I'll go ahead and pass them around. Once you get them, you have a total of 9 questions. Okay, 9 questions, so that means we want to shoot for that 100%, right? This is going to tell me, or we can get up to 7. 7 out of 9 is also going to be a passing score. So we want 7 or more questions correct. Okay, so we want 7 or more questions correct in order for you to say that, Ms. Robles, yes, I understand this. So this is going to show me as well that you are able to understand and master our objective from today. Okay, so we want what score?
7 or more questions correct.
7 or more questions correct. Okay, so I'm going to pass these around. Good luck to everybody. Don't forget to write your name. Okay. All right. You may begin. Of course, yes, you're showing work. Keep in mind that success criteria that we also have in the board. Okay. Does everybody have a worksheet?
Yes.
All right. Go ahead and get started. Go ahead and get started. Okay. So for this worksheet, you are exposed again to different types of models. We have circle models and we have bar models, okay? And this worksheet shows multiple choice answers, okay? And I see that you guys are following those steps, right? Of course, yes, you can use your worksheet, your scratch paper to show work. Your worksheet. Put them to the side, this one. Okay, so you have a total of 7 minutes. Go ahead. 12:27. Since my timer is not working. Question? Yes, of course you can write anywhere to show work, whether it's on your scratch paper or your worksheet. Okay? Yep. Yes, wherever you want. You can. Yes. Boys and girls, do we need to show work?
Yes.
Of course we need to show work. How is it that you're getting that answer? How is it that you're comparing? Yes, you may also use the timetables, right, for you to help you with multiplying those fractions. So yes, boys and girls, if you need that extra assistance in using your timetables, you may also take out your reference paper for those timetables. Yes. So with this one will be. Yep. Good. Bigger. Okay. Greater. I like how you guys are using that key vocabulary. Good job. Okay, we have about 5 more minutes. How are we doing? Sorry. All right. So first, good. I see that you were identifying the fraction on each model. Good. the greatest number. I know you like that. It eats the greatest number. Okay? How are you doing that? We're stepping into final fraction right here. How many slices in the pizza do you have in total? Count it. 1, okay, 6, and how many are shaded? How many did Nicole eat? 5. So we have Renzo. So we have 5 slices on Nicole's 8, and we have a total of 6. Okay, and this one? How many in total? 6, and how many slices did Nicole's eat? 2. So I have my 2 fractions. I'm going to go ahead and here, and I'm going to compare them. Use the butterfly. 10 up, 6 times 5. Yes. 2 minutes. As I'm walking around, I see that you guys are doing awesome. I can see clearly that you guys understood or are understanding our objective function. One minute. Show me your work. I want to see your works. This one is like that.
Finish.
Okay, STOP.
I can stop.
Okay. Now, before we close our lesson, I want you to think about, were we able to identify and compare those fractions with different numerators and denominators by using the visual fraction models?
Yes.
Okay, yes. All right, so very, very good. Okay.